Okay, hello everyone, and welcome back to my YouTube channel. As you must be aware, I am creating this series of videos um, to provide a short introduction about um, different devices inside the protection system. Okay, and today I have a very special situation because today I will not talk about a relay, a protection device as it. Today I will be talking about something that is extremely important if you are using wide area control and protections using phaser measurements. Um, um, mm, Today, I will be talking about one very specific element inside the protection system. And today, I will be taking a walk around the cell 2488. And the cell 2488 is a satellite synchronized network clock. Probably you are wondering what is the reason that we need a very precise and synchronized using satellites um, clock. Well, let me start this presentation talking about the motivation behind the use of synchronized time. Okay, I will start with a short motivation about that, about the use of synchronization time stamps for measurements, and then I will go for specific details of the cell 2488. And I will close this video switching on the cell 2488 and showing you some of the features during the starting up, during the starting up process of this device. Okay. Um, again, coming back to my original question, why do we need satellite synchronized network clock inside the protection system? Okay, well, this is a very simple explanation, okay? As you can see over here, there is a very small power system. They are basically few transmission lines, 3 generators. And here at each bus bar, I have include two representations, okay? For the electrical variable, let's say voltage at each bus bar, okay? For instance, here in this bus bar, I have on the left-hand side the phasor representation, and on the right-hand side, I have the time domain representation. The time domain representation is beautiful. You can see in blue color the beautiful sine wave, okay? But one of the issues when you are using sine wave is the mathematical problem of handling sine wave or cosines, okay? Many years ago, we started to use phasors. Phasors, they are extremely helpful for mathematics when you are running power system analysis. In fact, we use phasors for many applications inside the power system. They are extremely simple because you use complex numbers, you use a magnitude and a phase angle, and the phasor representation make the mathematics and the calculation simple. Okay? However, what is the problem? That phasors are representations of real-time domain variables. As you can see over here, I am presenting in this bus bar a phasor that is slightly to the left, and we can say that angle is delta 2. However, what is the understanding of this delta 2? Well, if you go back to the time domain representation, there is a green line, and that green line is representing the time for that very specific instantaneous voltage. For instance, if we go to the bus bar number 1, you can see here this location, we can say this is 0 degree, and that represents the maximum value for that function over there, okay? What I want that you see is that the green line represents the time location for the instantaneous value. Okay? Now, the question is the following. We love to use phasors. Yes, we love to use phasor, but the question is, okay, phasors, they are based in a vector that is rotating at constant speed. If we say those vectors are rotating at constant speed, we can define an angle, but that angle requires a reference. And every one of you must understand that that reference is a reference that is rotating at synchronous speed. As a consequence, when we define the angle delta 1 or the angle delta 2, we are expressing that angle in terms of a rotating frame, that rotating frame is at constant speed. What I'm trying to say is if we want to use the phasor representation, we need this synchronized frame to, to define all the angles against that frame. And that is where the synchronization problem starts. Because to define all those angles, I require that synchronized framework. Well, we love these phasors because phasors, they are very simple, and then they allow us to use the basic phasor representation to solve many problems. Here, for instance, you can see we are defining the power flow through this transmission line between bus bar 1 and 2. If we know the angles, we can obtain what is what the power flow is through this transmission line. But now, how do we do this synchronization? How do we create this rotating framework? Well, it's very simple. And that is where the satellite network that we have around the Earth is helping us. You must know that we have a network of satellites surrounding the Earth, and those satellites, they have very precise signal that allow you to capture and define time. To be honest, you can imagine that we have a transmission line, we have a circuit breaker here, we have a circuit breaker there. There are some measurements, and you must remember those measurements are coming from instantaneous values. The sine wave that I am presenting over there using blue color. But the satellite allow us to use this antenna at this substation and get with a very high precision, and we are talking about micro to nanoseconds precision, to define the time. If we define the time here and we define the time there, we can calculate angles inside the power system. And the modern electronic devices that we are using for protection today at various substations, they are doing the phasor measurement and creating those phasor representation. Again, what you need to understand here is that we need this very precise and synchronized satellite clock in order to create the reference for our phasor system. Well, now let me introduce the SEL 2488. The 2488 is a satellite synchronized network clock, and this clock is very, very reliable and very, very precise in terms of measurement. This device, the 2488, use the signal coming from a constellation of satellites around the Earth to get this time stamp that then can be used for many applications, including phasor measurement and including wide area control inside power system. Of course, this SEL 2488 require an antenna, and SEL provide to you a very sensible and very powerful antenna. and that is the SEL 9524B. That is basically an antenna with a very good sensitivity to receive the satellite signals and send those signals using a cable to the very precise cell 2488. Okay? That is basically the reason that we are talking about the cell 2488, because my research group, my research team, all of us, we are interested in wide area control with wide area protection, and as consequence, these kind of synchronized networks are very important. Something that you must know is that there are at least 5 different global navigation satellite systems. A lot of people, they are confused, and every time that you talk about global navigation satellite system, GNSS, they talk about GPS. GPS is one of the standard coming from the US, and that basically means global positioning system, okay? GPS is one of the types of GNS. There are others, for instance, the GLONASS, or Global Navigation Satellite System, okay? In this case, the cell device, the cell clock, the 2488, has the possibility of using at least both of them in order to define the proper timestamp that you require in your control and protection system inside power system, okay? Here on the left-hand side, you can see that there is a diagram showing you some of the potential use of this very important satellite synchronized network clock, okay? The cell 2488 has the possibility of providing time synchronization using several protocols, okay? For instance, one of these protocols is the Inter-Range Instrumentation Group Time Code B, or what we can call in short IRIG-B, okay? This is one of the protocols that can be used directly by cell products. For instance, in the lab we have the cell 411L, that is a differential protection for transmission lines. We will create a video very shortly about this very specific type of relay, but what you need to understand over here is if you are interested on synchronized measurements and synchronized trips of those cell 411L, you need to have synchronization, and this synchronization will be provided by the cell 2488. Inside the substation, you can have a big computer, data concentrator, and many other devices that they allow you control and protection in wide area context. As a consequence, the cell 2488 also allow you to create network time protocol, or NTP. NTP, Network Time Protocol, is another of the formats, and it can be inside the substation for these kind of situations where you need this kind of timestamp. And finally, also, the cell 2488 allow communication with other protocol that is the precision time protocol, okay? Don't be scared at the moment. We will be talking later about those communication protocols, because those communication protocols are extremely important if you are working inside wide area control and protection, and also if you are interested on phasor measurement unit. But coming back to the cell device in real life, you need to be careful, because the cell 2488 need to work together with the cell 9524B, and that is the GNSS antenna. That is the antenna collecting the signal from the GNSS system of satellites that is around the Earth, okay? For instance, if you are taking measurements using GPS signal, in this case, the antenna will receive signals around 1575 megahertz, or if you are using GLONASS, you are going in between 1570 and 1606. Okay, this is the basic explanation. Okay, something that is extremely important is that between the antenna and the device, you need to have a proper cable with the appropriate resistance. Okay, please check the user manual from SEL and you will find the proper cable that you need to use. Also, because the antenna can be installed outside and it's exposed to lightning strikes, we need to have a surge protector, okay? Also, please have a look on the user manual in order to get more information, okay? What I will do now is I will show you externally how the SEL 2488 look like, and then from there we will try to switch on the device and show you some of the very interesting features during the initialization process of this device. Okay, let's switch to the real device and start to talk about. Well, in front of you, you have here the 2488 satellite synchronized network clock. Okay, this is the SEL product, the Schweitzer engineering laboratories product. Okay, as you can see over there, this is the clock that will provide time stamps when you are interested on having synchronized measurements inside your protection system or control system. Okay, as I told you before, in order to get the satellite signals, you need to have an external antenna. And in this case, I am showing you here the SEL 9524B. Okay, this is the official and real antenna that you need to use with the SEL 2488 satellite synchronized network clock. Okay, of course, you need the connection between this antenna and the back plate of this device in order to capture the signal. Okay, this device, as you can see over here, there is an Ethernet port, and that Ethernet port can be used for communication. We will go in details later in a very specific video about how to set up this device, okay? Because at the moment, this device is coming from the bots, and we are showing you how the device look like and how the device behave exactly from the bots, okay? What I will do now is I will connect the cable, the antenna cable, with the antenna, and then I will switch on the device and make few comments about the synchronized clock. Okay. Now we are starting up the SEL 2488, and as you can see at the very beginning, the device is making a checkup and starting up. At the moment, the device is checking, and right now, as you can see, the device is showing the green color. The device is enabled, and the initializing process started. We are talking about 4 steps. The total time for this is around 5 minutes. Okay. Here you have some LED showing you some information. For instance, here the green one is showing you that the antenna is connected, properly working. You can see in green color. At this moment, the device is starting up and try to find source for time synchronization. Okay. As you can see over here, that is the first step. We are talking about that we are running right now by 53 seconds, and there is not satellite lock. What does mean lock satellite? That means that the signal coming from the satellites are coming into the device, and the device is able to process that signal together with some other satellites in order to define longitude and latitude, also to define the most important variable, the time stamp. Okay. Right now you can see over here the device is initializing, and it's step 2, 3. Right now the device is taking signal from satellites, specifically is coming from GPS, Global Positional System, the American one. And as you can see right now, we have the LED showing you green color because this device has been able to lock some satellites and is producing some information. Okay. This is the main screen that you can receive information, but also you can use the Ethernet connection to get more from that. As you can see, there are 2 buttons over here, arrows up and down. And here I am presenting some information related with the device. For instance, here you can see the serial number, you can see the part number, and specifically right now you can see that is presenting latitude, longitude, and altitude. Okay. As you can see over there, we are right now 59 degrees north because right now we are at my lab in Norway. Okay. And you can see over there the longitude is around 9 degrees, and the altitude is around 5 meters. Okay. Let me move to the next menu. You can see that the device has the Ethernet connector F, and you can see the IP address that we can discuss that later. I will run a very specific video for setting up the Ethernet connection of this device. Okay, I have a local private network inside the lab that is replicating the network, communication network that you have in a substation. As a consequence, you must be able to do and replicate the same things, okay? For that reason, I will dedicate a very specific video for that later. Over here, you can see how the antenna and the satellite clock is working, because you can see how many satellites are visible and how many of them you can use. Okay. If you look over here at the moment using the global positional system, you have 9 satellites and the clock is using 8 of them. Okay. They are not visible or use satellite of the GNSS system. Okay. If you want to see some other configuration, some other details, you can watch also my video in Spanish. I create also an explanation in Spanish about this network clock that you can find some useful. Okay. As you can see over here, I came back to the main menu, and you can see that the clock is still in initializing process, step 3 or 4, and you can see we have spent 5 minutes. Okay, in this case we have spent 5 minutes, and the clock is still waiting for synchronization. And now you can see that it's presenting the time, and you can see 12:33:09 seconds. Okay. I must be honest, that is not the real local time here in Norway. Okay. As I say before, this device was taken from the bots, and I am showing you the default configuration. This relay is coming from the US, United States of America, and as a consequence, you can see here that is using the the time zone for -7, okay? And over here you can see some information about what is the precision or the precision related with this device in terms of time, okay? As you can see, now the device is ready and up and is providing time with very good quality, and we are ready to use this timestamp for our protection system and for control system, okay? I think this video has presented to you so much information about the need for synchronization, time synchronization inside the power system. But it's time to finish this video today. We have been talking about the SEL 2488 satellite synchronized network clock, okay? In this very short video, I explained what is the motivation behind using a clock, a very precise clock inside power systems. Inside the substation, we need this clock in order to define timestamp. That timestamp will allow us to synchronize all the measurements, and as consequence, all the decisions, control actions, protection action will be on the same time frame. Okay, we switch on the 2488 network clock, and I showed you the initializing process, and you saw how the device start up, how many satellites the device can receive, and so on. Okay, but it's time to finish this video. I hope you enjoy and you learn something from this video. I know that this video is not for top experts, but young engineers and students will find this information can be helpful for the personal development and for developing wisdom about protection system. Well, it's a pleasure having all of you. Thank you very much for watching the video. If you feel okay, you can subscribe and keep in touch. And that's all for today. Thank you very much.